So the topic of today's lecture will be seeding, migrations, and query best practices. For now, these words may sound a bit complex to you, and maybe you hear them for the first time, but we will figure out it today. And let's go. So today we will make your database evolve without breaking it. And I hope that soon I can explain all the things that are covered by this sentence. The first large section will be connected with migrations. This word is probably a new word for you, and that is connected directly with your database. So why care? Okay, maybe I can hide that thing. Is it better? Okay. So why care? Just think about your application. For example, you have some set of features, but then something changes. And for example, that is a production project, and some client comes and says, I want to add something. Like here we have an example that we want to add a phone verification and then use this phone to send some SMS to user. But look at your users table. You don't have any phone there. So what do you think you can do with this situation? Like a straightforward approach, what would you do? Do you have any ideas?
I mean,
Add the phone row to the table.
yes, example is making a table, but it would obviously probably screw with our existing data, which would create probably big problems.
So yeah, if you have, for example, 3,000 of users and you will just create new table, it will cause some problems to migrate all of that data and to move it. So of course, when you work in team and you work on a huge project, you will not do like that because it breaks all the integrity and everything that you already have. So let's go. So what is migration? That is the thing that will help you with that. You can see here like an example that is a version script that modifies the database and captures that in the words. So what you have done. That helps you to change your database, add something, remove something, or change existing fields, and keep that in history. You can think of it as of GitHub, but not for code, but for your database. So when you push something to GitHub, it is a new commit, and you can push one more, and you have an option to revert if you don't want to keep that. So that is a version control system, but for database. So if to say in other words, it's just a script that helps us to capture the changes we are going to make. And like one more logic question. If you want to change some small detail, for example, here you are just installing a new TV set in your living room. You will not rebuild the house. So creating a new table is not an option. And we should understand that when we are developing things. So why to use migrations? If you work on your project alone, it may seem like a bit not needed because you can just go to graphical interface, that dbeaver that we installed, and you can add some column that you need and just use it. So it's possible to add column too. But if you have a big team, for example, 3, 5, 4 people are working on your project, that will be a problem because each person should have the database in sync and with the last changes, but that's impossible because you are doing something locally and not saying to anyone. So as described here, the project may have large team and the project may have multiple environments. that is a place where you develop things. For example, local, when you do changes in your code, development, when other developers do something, testing, where the QA part is working, and then production, that is the result that client receives. So all of that is environment. And just imagine doing that everything by hands on each environment and for each person. I don't know, maybe dropping a message like, I added some column you can add to. So it doesn't work. That is why we need migrations, because we cannot allow such things to happen, because it will break the whole project. So here we have a small diagram, how it works. And what is this Alembic? So Alembic is a tool that we use to work with migrations. There are other tools also available, but this one is the most suitable for our use case, and we will work with it. So Alembic has upgrade and downgrade functions. Upgrade is what is applied when you proceed with your migration, and downgrade is what is applied when you want to revert it. So it may be similar to commit and rollback in SQL Alchemy. So upgrade is a new commit, rollback is a downgrade. And also you can see this diagram. So if model change it, we are creating a migration script, then we review it. That's really important, because sometimes things that we don't want to have there may end up there. So it's important to validate it. And then we are applying it, and we get our database schema updated. So the goal is achieved, and we have the script. We can share it with some other people that are working on the project, and everything will be in sync. That is our goal, actually. So how this Alembic is set up for FastAPI project, for example. There is a full documentation available. I hope you will get a chance to read it more at home, maybe when preparing to do your task, because that is huge, and I'm pretty sure that it will figure out all the problems that you may face during the setup, but we also will do it later, so all is good. The most basic stuff is these 3 commands. Init migrations, that is to initiate that sub-application that will work with it. So it's like a separate folder, and you can see the structure. So the structure is that we have one more folder, versions, that will store these scripts that are generated, and they will have some sequence. Env.py is a configuration, how this Alembic knows what is it connected to, like your database, the URL, the password, the name. README is just to put your instructions. It is predefined by this package, but if you are adding something custom, you can also just store it there and use as information for all the new developers that are joining. And script.py Mako, that is not so important, actually. That is just a template that is used to generate the script each time. So the script has the same structure, upgrade, downgrade, like the ID of this change, and that's it. So the structure is like this. And of course, when you are initiating that, you will need to change some things. For example, this database URL with connection, because the package should know which database to target. So yes, let's maybe try it. Okay, it looks like I have to zoom in a bit. Okay, so you can see, I hope you can. I hope you can. Okay, I have that in my project, and how it looks like. I have some versions, yeah, but let's start from my database. For example, I have some pretty similar tables, like user and task. the same domain that I used in previous lectures. So the user can have multiple tasks. User can also have nodes that we can see here. And for example, I want to make some change. So I'm asking a question, what I want to do. And now I have an option to use my model for that because I'm already using that package. So if I will just add, for example, let's add some column status, change it. Is it better?
Yeah.
Okay, thank you. So I'm adding a column, status change it at, and for example, I want it to be date time with time zone. And also what I want to do is to make it nullable true. Because for now, we don't keep this column, we don't have it, but we already have something in our database. So it's also an important thing when you add some column, but you want it to be non-nullable. What will be with your existing rows? So it will probably be an error. So you have to think about it every time. Okay. Okay, so let's start. And for example, I want to add this column to my task model, and I will do Alembic, revision, auto-generate. What is this command? This command is used to create our script. I suppose it's not really visible because my terminal is really small. Sorry for that. Okay, so this command is used to auto-generate our script. And when we are adding something, we also have M option. That is a thing where we specify the message. And this message should be meaningful. That is what we want to change and what should be updated. So added status, change it at column. That is really important because that will help you later to understand what your change did without just entering all these files, checking everything and looking for the contents. Okay. Okay. Was pretty easy. I see the error. So if something is wrong, it returns the trace back. That is easy to read. As you can see, here I had a mistake, so I fixed that. And we rerun. One more mistake. Okay, so what is that? As we understand, something is not configured, and Alembic will say you that. So now it can't target my database. What I will do, I will check my files, and that is Alembic ini, that is nv.py, and in these files, you can configure your database connection. So if you use SQL Alchemy as a driver, and you do because we configured that previous time, you have to specify this main variable that is SQL Alchemy URL in your alembic.init file. And that is exact variable that will be used to target your database. So let's try again. Okay, target database is not up to date. Good. I think I would better explain all the commands to you, and then we will fix my issues. Okay, so what do we have here? We already discussed. And a bit more about Alembic ini, what can be stored there. There can be a script location, that is the name of the folder. And also you have the database URL, and all the things are predefined for you. You can modify them, but Like initially, you will not do that because that is really tons of these keys that you can change. And if you need, Alembic has all of that in your documentation, so you can read and just understand what you want to change. So a bit more about that nv.py file. That has the instructions how your scripts are run. For example, you can run it offline. That means that you just want to generate exact SQL, what will be changed, but without applying. That is really good to preview your changes just in SQL query that you don't have here because we use ORM already. And what you will use really often is run migrations online. That means apply to the database. Like all the changes that you have in your scripts, just apply them. And that is default. So by default, it runs online. So it applies all the changes to your database. And that is actually predefined. So all good, you just have to understand what is that. So you will not write these two scripts. And migration script, a bit more about structure. What is the structure? The structure is upgrade and downgrade, as we discussed. And Alembic also has such thing as OP. That is operation object, and it is used to change the database structure itself. So everything that you do is an operation, and to do this operation, you have to use this built-in OP thing from Alembic. And again, upgrade is what happens when we apply our migration, and downgrade is what happens when we roll back it. And here you have like a really short example with adding a column phone number that we needed at the very beginning. And of course, you can also have your downgrade that will drop some column from your database. So that's it. Let's go to common operations that you may have. I suppose it's pretty logical. So create table will create a table for you. And you have to specify the fields that you will need. And they are like data types, everything that you will need when you're creating a table. Drop table will remove the table from your database. Then the next thing is add column.
Oh.
Yeah, and drop column. So if you need to add some column, you specify the name, the data type, everything into that operation, and it adds a column to your database. Drop column just drops the column by name. Then alter column if you want to rename some column, for example. It was like phone, but you decided to name it more explicitly, like phone number, for example. And you want just to rename it, so you can use alter column for that. And of course, indexes, create and drop index for your field. And if you don't have suitable operation already defined for you, you can use execute. Execute allows you to write raw SQL query and just execute it on your database. For example, you want to do some operation with all the users, and you want to set that all the users are active now. So for that, you will need raw SQL query, and you can use it with execute. And also any custom thing that is not defined in these create table, drop table, add column, and so on, you can use it with execute. So also an important thing is Alembic versions table. So the versions table actually helps you to keep track of your history. That is added to your database. For example, your database already has users and tasks, but then you add this Alembic to keep track of your changes and your history, and it will automatically create for you a table Alembic version with one similar field that is version number. And when you apply your migration, apply your any change, it will just put exact current version number into this table so that your database knows on which iteration it is. If you have like 50 scripts, but you have applied only first and all the rest changes are not applied, your database knows about it. And of course, it will just migrate step by step. So actually, the key aim of this table is just to store exact script we are on. And again, you can think of it as of GitHub and Git control version system. So when you are changing something, you get a commit. Commit has some ID. And for example, some developer push it into your repository and you have new commits. So currently, locally, you are on your commit, but there are already other commits. So they also have ID, and it also helps to track the history. So the version number is current version ID. And also the commands that you can use with Alembic, that is actually to create a revision. You can auto-generate it, or you can fully create the script on your own. Of course, often auto-generate is used because that is simply faster. You just change your model, apply auto-generate, and it automatically works for you, creates a file, you will just review it and apply it. It's easy, it's good. But you have to review it. You really have to review it. And then next command is upgrade. You can understand what it does. It upgrades, applies your script, so your database becomes of fresh, later version, the last that you applied. The last if you use head. Head means migrate all the scripts till the most recent one. So I want to apply all the changes. You can also upgrade for one, for example, if you want to apply only one iteration. The same works with downgrade. You can downgrade, for example, to the previous one. That will work with -1. And you can also downgrade to a specific, this version ID. So if you want to roll back a lot of changes, you will just put this version ID. You don't have to know all these commands, but you just have to understand which opportunities you have. And you can, of course, check that in documentation when you need. So all good. The next thing is current. That helps you to understand quickly which version you are on. So just to get this ID and know which change is applied currently. Then history, that will print this linear history as git log does, for example. Do you use this command?
No.
Okay, it just prints the linear sequence of your commit. So what you have done, what you pushed to repository. Okay, so Alembic history works the same way. It will just print version by version so that you can check what is the sequence. Then we have Alembic show. That will just display specific migration content, what we have done there in that version. For us to understand, maybe we want to change something and something like that. And the last command, that is not often used, but it will be used in our use case. Stamp head, that is when your database was managed manually, as we have done with previous lectures, for example, but now you are introducing that control versions. So now we need to let Alembic know that all the changes that it can see are already applied when we start, because we already have that database. So it's just a structure that already exists. That is why we need this stamp head command to just understand and apply that our existing schema is already up to date. Okay, so I think now we can go to Alembic. And you can see that I have, for example, my SQL Alchemy URL, as I already showed. And I can just check Alembic current. And it returns some version. So if I want to do Alembic upgrade, for example, it will just apply migrations. And which migrations do I have? Here I created this status changed at column. I suppose it was not created because my database was not up to date. So let's retry it. Now I want to add this column finally. So I see that something happened, yeah? We have all these info logs to understand that something was added or something changed, and it lets me know that it's generating a new file for me. And I see this ID, DCF, for example, and then I go to my versions folder, yeah, you can see it, and I see this migration. Second. And I can see that the file contents are exactly like what I wanted to do. That is add a column to task table. The column name is status changed at. Here is the data type and nullability, like true in my case. And downgrade is also created automatically. So if upgrade is adding this column, downgrade is removing it. So that you can go forward, but you also can have an option to drop this column later. If, for example, you will not need it anymore. And here, what is this version number in your Alembic versions table that is added to database? That is actually an ID. An ID is revision. That field is generated automatically, and that is current version number. What is down revision then? What do you think? Do you have any ideas? That is a previous migration. So that we can build this like in such way that we have some current point, it has some ID, it's like other, but let it be one. Then we go to the second point, it has some ID, but it also has a reference to what was done previously. So we can go to third, for example, and add one more field, but we also have an option to revert back to second, and we also have an option to revert back to one. And it really helps when you work in team, because changes may happen and all the people have to be in sync to work on the one project. Yeah?
Okay. Example, we did some changes in a few versions, and then I want to revert like only change that had been done on earlier version. Can I do that, or should I?
Like, you mean if you are already...
For example, we are right now on the version 3, but I only want to revert changes that were on that I did on version 1.
Yeah, it's possible, but it's done really like in manual sequence. And what is better to do, like if you are currently, for example, let's have some use case. We added this status changed at. Plus, like added a column. That's for first. For second, we, for example, removed minus what we can remove from task, status. I don't know why we do that, but let it be. We removed some column, and then a third, we added some, for example, assignee to the task. And now you are at point 3, but you want to remove the changes from first thing. So let's think like how it's best to do that. In most cases, developer just check what was done here and creates a new migration. Because you can't just skip and go to this. If you want to revert, you have to revert everything. So it's easier just to, oh, I added this status change it add. I will create, okay, why it's not working? I will create a new and remove this status change it add. Because it's just easier to manage than going back to the first state, because you have to remove assignee again. It will just drops the data from your database. Then you have to add status because you removed that. And then you can only work with version 1. Okay, thank you for the question. It was really good. Then what we have, for example, you have some field that should have a default value. I suppose you have already done that in your like SQL database, that you are specifying that some field has a default value. Have someone tried?
I think at some point maybe.
Yeah, we covered that, but it depends on your domain if you added that in your homeworks or not. So actually, yeah, we can have a field and specify some default. It can be some text value or some date time default, something that is applied if you don't put anything in that field by your own. So here is also interesting thing. We have a default and we have a server default. A default is handled fully in Python. And if you will use your database without Python, it will never be a default there. So if you just running a raw insert query, it will not know about any defaults. And server default, when you add some column that has server default specified, that means that if you will use your database without Python at all, it will apply it as a default because this change is captured at PostgreSQL level. So your database knows that it has some defaults. That is just an interesting thing for you. So if we are going back to migrations, what are common mistakes? Why do we need migrations? Because editing database manually can bring us a lot of problems, especially if there is some data in our database already. And migration is also good because when we create the script, we can see the full content, what will be done. And if we want, as I mentioned previously, we can also check the raw SQL that will be generated by this migration. So we can just validate all the changes and think one more time, do we want them to happen? But if we are running some just pure SQL query, we will just click enter and all the data can disappear if something is wrong. So it's not really good. And we also do not track this, and other people will just don't know about it. So next thing is forgetting to create a migration after model change, because if you forgot to do that, then you will not have that change in your database like exactly, and only your model will know that some field is added. So it's not applied to the database until you create and run your migration. Then running upgrades in wrong order. That's also important because, for example, you can just mask your history of these migrations, change something manually, because it's also possible. You have seen that file, that's just an ID, you can remove it, insert something other thing, and it will not bring you a good result with database integrity. You can also like corrupt some data, maybe delete it at all. So yeah. Next thing is about production projects world. When some database states are mixed, so if you have some changes in your local database, but you don't have them like in your production database, or maybe other way, something is happening in production, but you don't have it locally, it can also bring you a lot of problems. And you can think of it like as you are working with your teammate, someone does something, other person doesn't know. And if you both do that at the same time, what will happen at the end? Okay. And not checking the script before running it, that is a real problem, because sometimes this auto-generate can capture something wrong, for example. So we really need to validate it before running, and we have to understand what will be applied. That's really important. Okay, a bit of practice. Let's start from the very left. Do you have any ideas what is happening in that script? Like, what is the goal of the whole script? We have here alter column, create table, and create index. So if we can just describe, someone can describe.
First of all, alter column renames the column full name to display name. Create table creates a new table called user logs, and as I understand, adds a bunch of columns: IT, user ID, and action. Action is the first two are just strings. One first is the ID is the primary key. User ID can't be null. No, can't be null. True. Null is false. And action is just a string of some kind. And create index creates an index for like the index is called ix underscore user underscore logs underscore user underscore ID. It is put on the user logs table, which we just created, and on the column user ID, which is also just created. That's it.
All right.
Someone else do another one.
Yeah, let's go with second, that is from top. Any volunteers?
In the add column, we add the column.
Let's try, guys.
So
It's not so hard.
can you hear us? No.
Okay, let's.
Upgrade. So we add new column to table tasks. We add column name owner ID, and it also can be null. It can't be null. After that, we create foreign key, also for tasks, and reference foreign. Okay, so it takes some like foreign key from users and puts it into tasks.
Like it creates, yeah, foreign key for table tasks and for this owner ID field that we added previously. So it connects, like when we add an owner to the task, an owner should have a reference to users table. So that is this reference. So it's correct. Okay. And the next thing?
Literal package.
Yeah, like, oh no, we are removing the assign it to column from tasks.
Drop is deletes all.
Yeah. So here, all three cases are upgrade. We don't have any downgrade example here. Okay, and what is this at the bottom? Who wants to describe?
Some people of line are saying that you don't hear us. You don't hear them. They try to say something.
Oh. Okay, so maybe someone online wants to describe this like last script.
Okay, so in the last one, we add the column with the name to the table users, and the column is named is active, it's Boolean type, and the default is true. And then the next one, we create an index for the table user and connect it to the column emails, and it should be unique. I have a question. Maybe it would be like a little bit of a stupid question, but what is OP and SA?
Okay. OP is what I described like at the very beginning. That is a built-in Alembic thing. OP means operation. So we have a bunch of operations. For example, here, alter column, create table, create index, add column, and something like that. So all these operations are registered at Alembic level. And we use this OP to call some operation that we need to execute. And SA, that is an SQL Alchemy, like a shortcut. So when we are adding some column, we are calling SQL Alchemy column and then SQL Alchemy integer, for example. That means that we want to create a column of type integer. So when we are changing, when we are changing something, we need to use this OP and SA, that is meaning SQL Alchemy, and OP is meaning operation. Yeah, thank you. So yeah, here we just have everything described. That was already done by you. Thank you, guys. And then the next section. The next section will be about seeding. Have you heard about it something? Do you know what is seeding?
I heard the term, I do not know what that is.
Okay, so you will know it soon. So what is seeding? Seeding is adding some initial data to your database that helps to start project with some ready-to-use data. For example, as you are showing us your assignments and you want some data to demonstrate it on, and you just add something random, like random, for example, books and authors, just random values to have some data to demonstrate it on. So seeding is actually used for demonstrations, for tests, also for some default values that should be in database. And that can just help you to check that everything works correctly, and you can fast seed your data and use it. Or, for example, use it for some QA engineers that are going to check everything and they need really a lot of data to work with. So Python has some packages to work with seeding, and these packages help us to make our random data a bit more similar to its real meaning. For example, such library is Faker. Faker actually name says for what it does. It just fakes with some random data and creates for you some records that you can use. This really easy and short example shows us that we can create a user and we can use our faker to insert some random name, random email, and random city. And this library already has everything included. You can call some variables like email and it will generate something that looks like email with this domain at the end, for example. You can call city and it will pick some random city, I don't know, London, and it will insert for you. So it's really easy and fast and a lot easier than if you do it
by your own hands. So it's just a really good option to test things and to run such demonstrations quickly. Also about seeding, an important thing is to have idempotent seeds. Idempotent is safe to run multiple times. So if you have some seed script, for example, your default seed script is to create an admin in your system so that when someone starts your project at its own local machine, this person can just quickly create an admin. But you don't want a lot of admins. So if admin already exists in your database, it should be skipped. This operation should be just skipped and nothing will be applied, no changes will be added. So here we have like a check. If we have some user, we will not create it again. So idempotent means just that it will prevent from rows duplicating, and it is useful when you rerun your seeds for some reason, or if you have multiple environments, you can't be sure how users use your scripts to run seeding. So that is really important. Let's check it. I also have an example for you. For example, we use this Faker. Faker can be installed with pip library, like this library can be installed with pip, sorry. And then you can just import it from Faker, import Faker. Then you initialize it because this thing has a lot of predefined words, variables, and everything. So you have to initialize it. And then, for example, we are making our tasks. I hope you can see it. Yeah. So we are creating our tasks and we are assigning some user ID from the users that already exist. Title should be like a sentence. We can even fake a sentence and set like how many words we want in that sentence. Then we can fake the description. That means that it will be really something larger than one sentence. So we use a paragraph for that. And we also can like make our set of things to choose to be fixed. For example, we have our task status. We don't want really random there because we have some statuses defined. So we have our status and we can also say to Faker, hi, pick a random element from my task statuses. But for that, we have to define our task statuses. For example, in my case, that is new, in progress, blocked, on hold, completed, or canceled. So we can use this in our Faker, and it will just pick something from that predefined list. The same with priorities. We also have it defined somewhere, and we don't want to have a full random there in that field, because for us it's important for filtering, for example, and for other purposes. And we also can fake our dates. Faker allows us to use like future date to set some end date that will be in our task as a due date field. Okay, we can also run it. It has some multiple scripts there, but okay, and I have error. Good. Okay, I suppose I forgot to run my script. Yeah. So now, for example, I created my tasks, and here I'm just adding it, like 4 tasks already stored, skipping new ones. Okay, I suppose it was because I run it for multiple times, and that seed is idempotent, as we already discussed. But I hope you understand that we can just use Faker to like make some not real data that we can use to create test data for us. Okay, sorry.
Have someone heard about such term already?
Haven't we talked about that when we learned about like middleware and stuff? Or maybe.
Yeah, would be with Aura.
Yeah.
So, what is transaction? Transaction is a group of some database actions that should succeed or fail together. Like, for example, something that depends on each other. Yeah, and you can see this image, like when two users are booking the same room at the same time, like the developer hasn't predicted that, there could be problems, but that is actually a bit more advanced. So transaction is a group of actions. That is what you have to know for now. And these actions depend on each other. For example, we have such a case to just understand better why do we need transactions. For example, you are booking a flight and you pay for your ticket. After that, we have to mark somehow that this seat is taken by you because you already paid your money. And then we have to send you an email confirmation. So if you have already paid for your ticket, but then like this succeeded, your money are gone. But then seat cannot be marked as taken. For example, some error happens. What will happen if you just do it separately? So money are gone, but you don't have your seat and you don't have confirmation, so you don't have money just, and that's what you have. But with transaction, you can execute it as a group of actions. And how it will work? You pay for your flight ticket. This action is in queue. After that, seat is marked as taken. If already like it's succeeded, we go to the next step. We send an email confirmation. After that, we commit that all to the database, and it works as expected. But if some error occurs at seat booking, you have to get your money back. It's just a rollback action because these actions depend on each other. So why do we need transactions? To just have, just to be sure that everything is executed as expected. When the action can have more than one step to be completed. Like here, yeah, we pay money. After that, we book a seat. After that, we send some confirmation. So if something of that fails, it would not be a good user experience on your website, especially if that refers to money, because it's a real problem when something goes wrong and a payment succeeds, but a person doesn't have what he or she paid for. So you can see this flow. With transaction, we have to begin the transaction. That is a block where we specify that our transaction starts. After that, we charge user, reserve seat, send confirmation. If all good, we make a decision. If all good, we commit that to database. If something failed, we roll back. So the whole block is executed or just roll back. So yeah, but without transaction, you just do all the actions as you would probably do this. That is charging user, reserving seat, sending confirmation. And if something goes wrong, you get inconsistent database and unhappy users. Okay. So what is rollback? Rollback means to undo all the actions in a transaction if some failure is detected. when it happens automatically when an error occurs. It returns your database to the state that it had before the whole transaction, and it guarantees consistency for you. So you don't have something half changed or half executed. You have everything or nothing. That is the best thing when you have some dependent actions. And now, I suppose, let's go to query optimization.
Maybe as for previous, like
Yeah,
first
do you
we
have
start
question?
user, after that we want to reserve seats, after that it can be failure, so it will be a rollback. Do we need like some other function to return this charge for user, or how it works?
Yeah. Ideally, if that comes into work with money, we have to make a refund in such case and just return money to user. So we have to trigger that action, like we have a failure, please return that money. But that is just an example to understand how critical it can be. So when we have to book all these actions and group them together and execute or not. But yeah, when it comes to money, that could probably be a separate action to make a refund, or you can just make it a pending operation that I have to, make some charge from this user, and when everything can be done, all succeeded, you make this charge, for example. And if charge successful, you mark this seed as taken. Yeah. Okay, thank you. So query optimization part, I suppose you all know that we can make queries good, but we also can make them bad if we don't know some important things, or we just don't check them with explain, for example. We don't see what exactly is executed, and we can get poor performance as a result, especially if we have a lot of rows in our table. So if we have 3 users, we will not see any issues. But if we have 3,000 users, we can see the issues. So why care? Because slow queries mean you have a slow app or website, because your users will get not really good experience by using it. Also, inefficient database calls waste your resources, because database uses some resources on your computer, and in larger projects, when they are already hosted, for example, Spotify.com, like you enter some website, it is hosted somewhere, so it uses some resources, and some people pay for these resources. And if you have inefficient database calls, they are just using a lot more of memory, a lot more of resource to run on, and you are just wasting the resources and paying more. Then bad joins and N+1 queries, they make unnecessary complexity. And if you write some really complex queries that could be written more easy, you have a risk that something will go wrong just in logical part of that query, or in some other part. So it's like the complexity that you don't need. So that is why it should be solved. Okay, N+1 problem. What is N+1 problem? That is when you have too many small queries. Do you understand what is or may be the issue on this screenshot? Maybe Maxim?
So when we create a
Okay.
query using SQL Alchemy, it just iterates, like creates a lot of queries based on user index. So each index has its own query. So it's going to be like N+1 queries for this simple problem.
Yeah, for tasks. Yeah.
Yep.
Like to load the tasks. Yeah, that's correct. Because as you can see in this code, we are just fetching users without prefetching its tasks. So in this loop, we will just query like to get tasks for each user. So we do what? We are loading all the users. That is one query. And for example, we have 5 users. In this loop, we are calling tasks 5 times, like for each user. But we can do like this. We can use select in load, and that will make also a subquery actually, but it will be a one subquery. So we are just fetching all the users and prefetching their tasks. And in that loop, we will not run any extra queries. Everything is done already, and it costed us 2 queries instead of 6, for example. If we have 5 users, we are loading users, that's 1 query, and 5 times tasks for each user. So the second option is better because you don't trigger your database in the loop, and that's really important thing to try to do. And you have to notice such things, because if you are loading some relation, it's really important to think of, do I need maybe a preload? Will it work faster or not? And also the previous lecture, we had a mention of echo there. Echo helps us to see what queries are sent to our database. So if you use this echo, you will see that it's like spams your database. So you have to do something with it. And this solution with using select in load can help you. There are also other loading strategies, for example, joined load or subquery load, but it depends on your use case, and selecting load is also often used. You will have that in materials, and you can just write some questions if you have. Okay, the next thing is overfetching. Overfetching happens when you ask for too much data that you don't need for your purposes. Let's focus on our use case. We have to show task ID and the title of the task and at the overall tasks page. For example, we have such page, like the tasks, name 1, then name 2. It's probably guys online can see that. So actually, let's focus on our use case. We just have to show ID and title of task. So what is the issue at this screenshot?
Maybe we need to select not a whole tasks like module, but just task.id and task.title.
Yeah, that's correct. Because we don't need all the fields, and sometimes it costs not really a lot of time. But if you have 40 fields in your model, for example, it will be really a noticeable change. So if you don't need something, don't query for that, because that is simple, and it can also help you to avoid some bugs, to make your queries faster. And if you don't need relations, also do not include them, because you don't need them. So the simpler, the better, and keep it simple and easy to understand and to work with. So overfetching, we solved that problem. Okay. Next, inefficient filtering. So what is inefficient filtering? It happens when you make your database fetch too much, and then you apply filter later. For example, using Python code. Not at database level, but later somewhere in Python code. So use case, we want to get active tasks. Active means not archived. So what is the issue with this tasks query and this filter? Max, maybe you want?
Yes. We're doing we are getting our variable active tasks through just Python stuff instead of using stuff like select, group by, etc., etc.
Yeah, so the issue is that we really use Python code. And what will happen? We will fetch all the tasks that we don't need. And then in Python code, we will change something, filter something, and get our result. But it will be a lot more slower than just fetching from the database what we need. So we need a task where is archived is false. That is a simple filter, but it saves a lot of time. And also, like just from software design side, filtering something in Python when you can do that in database, it's like one more code block or something, like one more function. Why do you need that? You don't need that. So it's better to do on database level. It will be faster and better. Okay, so no pagination. For example, when you query tons of data from the table at once, it can be really slow, because even if you have some, again, tasks page in your application or your website, even if that page like doesn't have visible pages, yeah, to 1, 2, 3, 4, 5 to go just like with bunch by 10 tasks or something like that. Anyway, your user will not scroll everything, all the 1,000 of your tasks at 1 second. And you don't need to query everything like in one fetch, because that would be slow and a user will wait for your 1,000 of tasks while he wants just to check first 3-1, for example. So the use case is to get all the tasks available, but from the design side, we want it paginated. I will show that just to explain you a bit more what pagination is. So it helps us to create these pages. As you can see somewhere in websites, when you check some data, you can go to page 2nd, to page 3rd. So the data is splitted by parts for you. And we use limit and offset for that. Limit is how much rows you want to fetch with your page. And offset is this change for database. Like, for example, I'm on page 2 and I want to fetch 10 rows. So offset will be just limit multiplied by page -1. So the database knows from which row to start executing for you. So it depends on the page you are on. So if you want to check some tasks, for example, and you have 1,000 of them, you will wait probably 3-4 seconds, depends on how much stuff you are loading. But if you will use pagination and you will specify like, it's page 1, I want to get 10 tasks, you will get 10 first tasks and it will cost you milliseconds, but not 3 to 4 seconds, or maybe a minute. It depends how much tasks you can have. So here it's also explained. Limit is how many items you want to see on the page, and offset, how many items to skip before starting to show. And also what is important, if you use pagination, you probably want to order that query set, like all your rows. because every time your behavior may be random. Like if you do not have ordering, you can have a random results. So if user enters tasks page for the first time, it sees like some 5 tasks, like create database, I don't know, create a table, something like that. Then user refreshes the page. We are doing it all again, and other tasks will appear. So we have to do ordering when we use pagination. And even if we don't use pagination, doing an ordering is really a good stuff to ensure data consistency. So here, for example, it's created at column. We can order by that and be sure that every time when we are loading our pages, we get the same results. Do you have any questions maybe for them?